Separate our variables. We ready? So let's separate. So we're going to have the 1 over the square root of x minus 3 dx. And then we're going to divide the y over to the other side. So we're going to have 1 over y dy. So remember, we said if you don't do this step, you get 0 points out of either 5 or 6 points. Okay, so we don't want to do this. You have to separate your variables. And then you can put your integration sign in front. So we're going to get the natural log of the absolute value of y dy. And then on the right side, it's a u substitution problem. Some of you guys are going to be good at these without writing the u, but kind of go through this process and say, okay, my u is going to be x minus 3. My du is going to be dx. So when I replace, I get my u raised to the negative 1/2 du. So when I integrate, you should have u to the 1/2 with a 2 out front. So we're going to have 2, and then the square root of x minus 3, right? That was our u to the 1/2, and then plus c. Now we plug in our x and our y. Oops, I don't know why I did natural log of y dy. No one even asked me about that. All right, natural log of negative 1, and then I plug in the 4. So I have natural log of 1, which is 0, and I get 2 times 1 plus c, so c is negative 2.
So instead of getting the 1/2, you just did the square root when you plugged, did 2 square root x plus 3?
When I integrated, I added 1 to the power, right, and then I did 1 over that power, which gave you the 2.
Okay, like when you plugged in u.
Yeah, I just put the square root part in, yeah.
Okay, so we have the dy and dx, and we have the plus c for the plus or the dx, but why don't we have a plus c?
You could put a plus c, but it's kind of redundant because that's like 2 different constants, and really you could just add a single constant on one of the sides. So I typically just add it to the x side. I don't add it to both sides.
Wait, where did the 4 come from?
It's from the point, like this is the point, 4 comma negative 1.
Wait, why don't we add it to both sides?
Because adding c to one side, I mean, I could add it to both sides, but I could also subtract that second c over, and it's still adding a constant. Like if I had like a plus 5 on this side and a plus 11 on this side, couldn't that just be plus 6 on one of the sides?
Okay.
Does it make sense?
Okay.
All right, so I get the natural log of the absolute value of y equals 2 times the square root of x minus 3, and then I put the c back in, so I have minus 2. Okay, so we did not talk about this much yesterday, but as I told you, the joys of AP Calculus exams, every year they just add a little bit of fun. Just a little bit of something a little bit different. So the thing that they're adding to these is a restricted domain. Okay, so do you remember those beautiful sketches of slope fields that we had, like things like this, these beautiful slope fields? When you draw the solution curve in, there's only a single continuous curve. So do you guys see this beautiful curve here?
Yes.
That's one curve. It's not like we had one curve and then we had an asymptote and then we had the second curve. Okay? So you're never going to have a solution where it's like, you know, here's one curve and then here's the rest of it. It's not going to be like that. It's just going to be a continuous curve. So this is part of differential equations. It's a weird rule, but you have to have a continuous curve. Okay? So when we look at our domain, you'll often have things that are going to affect our domain. So things that affect domain, natural log, right, logarithms, denominators, square roots. Okay? In this problem, we have a square root. So we do have a natural log as well, but for the x's, we have a square root, right? So what is true about this domain? What can I not have? I can have 3. I can't have things that are smaller than 3, right? So I would write x has to be greater than or equal to 3. That's your domain. But we're going to have some other examples, and sometimes it's going to involve natural log. So if you have something, so don't write this, but if you had natural log of like x plus 5, it's in absolute values. Yeah, Grant.
But if x is 3, you can't take
Square root of 0 is 0, so that works. Yeah, so you can count that one. But if you have the natural log of x plus 5, there's only one number that you cannot have in like the natural log of the absolute value of x plus 5. What can I not have? Negative 5. Could I plug in like negative 6?
Yeah.
Sure, because it's in that absolute values. Do you guys see that? So I can't take the natural log of 0. So in this case, you would think about the two pieces of your domain. You could have x values that are greater than 5, and you could have x values that are less than 5. And then you actually have to choose one of those sides. And that's always based on what original point you had. So if your point was like, not 5, whoops. If it was like 10, comma 2, right? Your x value is 10, so you'd pick this. But if it was like -4, comma something, you would pick the other one. Okay, and we'll do some examples like that in a second. So don't be like totally confused yet.
Would they ever put a point in between?
No, it would not. Yeah, because that's not part of the domain, right? So it wouldn't be. Yeah.
So no solution is never the answer.
Well, no solution can be the answer. I don't know. No, not on these differential equation ones. I've never seen a no solution as the answer
And
for
if it were
differential
like
equations.
1 over x minus 3, x couldn't equal 3.
Right. Okay, and then you have to pick one of the two sides of that domain. All right, so if I have this, I'm going to go ahead and solve for y.
Why would a restricted domain like y could y equal 0?
Yeah, so, and that's a good question. I've never seen them ask for the restricted range. Range is y values. But it's always good to kind of keep in mind, like this one, if you have the absolute value of y can't be 0, right? So that means you could pick between the two sides, y is greater than 0, or y is less than 0 and y is greater than 0. And then you could say, well, based on my point, my y value is -1, so I guess I got this one, and then cross the other one out.
Okay.
So you could do that. All right, so now let's go ahead and solve for y. So I have natural log. How do I get rid of that natural log? E. So I'm going to do e raised to both sides. So it's going to look like natural log of the absolute value of y equals e raised to the 2 square root of x minus 3. Oh, dang it. That's what I get for doing it in different colors. All right, there we go. So we get that. And then we do our plus or minus. So I get e to the 2 square root of x minus 3 minus 2, and I have that plus or minus. All right, so now last step. I think we did one like this yesterday. We have to make a decision on that plus or minus. Did we do one like that?
Yeah.
Okay, so remember, we go back to our point. So we go back to 4, -1, and let's plug in 4. So everybody kind of do this with me. If I plug in 4, I have 2. The square root of 4 minus 3 is 1. 2 times 1 is 2. 2 minus 2 is 0. What's e to the 0? 1. I have plus or minus 1.
Negative.
Which one do I want? I want the negative, right? I wanted a -1 right there. So I want to plug in a 4 and get a -1 for my y. So your final answer then is y equals negative e to the 2 square root of x minus 3 minus 2, like that. And then if it asks for the restricted domain, it would be x is greater than or equal to 3.
So on these, is it not accepted if natural log is part of the problem?
What do you mean, is it not accepted? Is,
We have the answer as natural log of absolute value
yeah,
y.
typically we solve for y if possible. If it's
Alright.
something that's not a function and you're unable to solve for y, you can leave it. So the ones where you can't solve for y are typically like multiple choice questions, and maybe they'll write it in a different way. These are like free response questions here. All right, so this one, same kind of idea, but it's phrased differently. So it says, find an equation of the curve that passes through the point 0, 1 and whose slope, well, slope is dy over dx, right? So whose slope at the point x, y is xy. So we write dy over dx is equal to x times y, and we're at the point 0, 1. So we find that. Oh man, it's like really yelling at me now. All right, so I'm going to separate my variables. So I'm going to have 1 over y dy equals x dx. And I integrate. So I get natural log of the absolute value of y equals, and I integrate x, 1/2 x squared plus c. Make sense? And we plug in the point 0, 1. So plug in 0 for x and 1 for y. Isn't that nice of me? What's c? 0. So we get natural log of the absolute value of y equals 1/2 x squared. You can write plus 0 or leave it off. And now we solve for y. So we're going to do the e raised to both sides. So I get the absolute value of y equals e raised to the 1/2 x squared. So I'm going to write it as e to the x squared over 2. That way I don't have that like 1/2 in front of it. So x squared over 2. And then we get rid of our absolute value by doing plus or minus. And then we make our decision based on our point. So we're going to plug in 0 for x. And we want to get 1 out. Yep. So Julia, which one did you say?
Positive.
The positive one, right?
Can we just assume if, or is that just a pattern of notes? That if it's positive 1, it's just going to be plus
That makes sense, right? Because you're solving for y in the end, right? Y equals, so y has to be a positive number then. Yeah. So it's not a coincidence. It's always good to show that stuff, though. All right, so we get that. Now let's go back and think about if we had a restricted domain. Did we have anything affecting the x values that made it undefined? No. Did we have a restricted range, though? Yeah, so if you want to write the restricted range, you can. So the only place that we can't have is 0. So we would have either y is less than 0 or y is greater than 0. And then we pick between those two based on our point. So our point was 0, 1. So our y value is greater than 0. So that would be our restricted range. So if you have that on there, maybe you'll get an extra point, right? Maybe we'll say something about restricted range. But usually it's restricted domain that you're worried about. Okay, so number 3. This one's a tricky one. Let's see if anybody gets it. So it says solve for y if dy over dx equals e to the x minus 2y. And our solution curve goes through the point natural log of 2, 0. So I said use exponent rules to help you. So are you guys noticing that this is really hard to separate? You can't do natural log because then you have the natural log of dy over dx. It gets a little weird. You could try. Do you do a what? Maybe, not quite though. Gotta figure out how to separate those variables. Here's my hint.
Oh.
And something plus minus e to the
What do you think, Emerson?
e to the x.
No. So if I had x to the 10 over x to the 4, do you guys remember how that's 10 minus 4? Let's go backwards with this one. Creepy.
That door just
I know. I feel like there's a ghost coming in. All right, so I get e to the x over e to the 2y. Do you guys see how that's equivalent to the thing above it? It's hard. They don't ask ones like that, I don't think, on the... I wouldn't think they would ask that on the AP test, but you never know. Have you guys ready for anything?
No, wait, never.
Yep. All right, now we separate. So let's do e to the 2y dy equals e to the x dx. And then we integrate. Are you guys good at doing e to the 2y in your head? It's through a u substitution. It's letting u equal 2y. So du is then 2 dy. So we gain a 1/2 when we replace. So if we replaced, it'd be e to the u with a 1/2 du. Right? So this is going to be 1/2 e to the 2y when we integrate. And then equals e to the x plus c. Then we find our c. So I have e to the natural log of 2 plus c equals 1/2 e to the 2 times 0
Where's that natural log come from?
from this point. We're trying to find c. We'll plug it in the point. That's like our x comma y, our point.
Yes, but what is the natural log?
Because that's what I made it.
Oh,
I tried to be nice to you. I mean, be nice, because what's e to the natural log of 2? 2. So I tried to make it something that was going to be nice. So 2 plus c equals 1/2 e to the 0 is 1/2. So then c is equal to negative 3 over 2. I don't know if I made this problem. I think I took this from a book.
Oh, that's not original.
They're hard to make sometimes. It's hard to make nice ones.
Original content. Download.
All right, so now we go back. So I get 1/2 e to the 2y equals e to the x minus 3 over 2. And we can clear by multiplying through by 2. So I have e to the 2y equals 2e to the x minus 3. So I can clear that 1/2. Then we got to get the y by itself. It's a really weird answer. So what's the next step to get the y by itself? Natural log. So we're going to do natural log and natural log. So I'm going to have no more e. So 2y is equal to natural log of 2e to the x minus 3. And then we divide everything by 2. So it's like that. Sadly, I don't know if there's a way to simplify that. That's it. Fun, fun. Yeah. All right, so at any point, did we have anything weird with our domain? No. Yeah, so I think we're good. I'm trying to think of that one. I don't know, if you had a 1/2 in front of the natural log, that's actually a square root. So you might actually see it written like natural log of the square root of 2e to the x minus 3. So that one, it could ask for a domain, I guess, because you could set your, figure out when that's equal to 0. But I don't think they would get that difficult.
So it's over 2, that's right.
Yeah, because that's like a 1/2 out front, and a 1/2 you can pull up as a power. So kind of annoying. Natural logs are annoying. There's lots of ways to simplify. All right, so are we good there? All right, let me stop this and I'll